Okay, hello class. So today we're doing some stoichiometry. So first we're gonna,
the
first question we're
calculate
answering.
the mass percent of carbon in the hydrated form of the solid that has the formula BeC2O4 times 3H2O.
Okay, so the first thing you're gonna do is you're gonna find the total AMU of the whole equation. So that's gonna be the AMU of BE plus AMU of C2 plus the AMU of O4 plus the AMU of 3H2O. And that is gonna equal 151.08. After you do that, since we're trying to find the mass of carbon, you're gonna take, we're trying to find the percent of carbon, you're gonna take the AMU of the carbon of the C2, and then you're gonna divide that by the total AMU, and you're gonna get 0.159.
Which you're gonna multiply that by 100 and you get 15.9%, and that is how much carbon is in this molecule.
Great. Okay, the second part of the question is...
Wait, let me read it. It's called, when heated to 220 degrees, BeC2O4 times 3H2O dehydrates completely as represented below. BeC2O4 times 3H2O, which is a solid, results in BeC2O4, which is a solid, and then a 3H2O, which is a gas.
Okay.
If 3.21 of BeC2O4 times 3H2O is heated to 220 degrees, calculate the mass of BeCt04 is formed.
Okay, so the easiest way to do this is create a BCA table like Mr. Bresser always says. So we've created, there's a lot of stuff on here, but basically, since you're trying to find the mass of BeC2O4, first thing you're gonna do is you're gonna take the total AMU of the whole thing, and you're gonna minus the H2O AMU because we don't need that because we're just trying to find BeCO. So, and then that's gonna get you 97.03. Great. So then we're gonna do is we're gonna form the BCA table. Now, what the BCA table is these are the molar masses, right?
Change after.
Right. So this is the molar mass of the BeC2O4 times the HO3, and obviously these are going to be 0 because we haven't formed anything yet. And then the change, we're minusing the 0.01212 because that's the only thing we can minus. And then so we're going to end in 0. For this one, we're adding 0.0212, and then so we're equaling that. And then for this one, because it's the what's it called? The water, we're doing 0.0637, and the reason we got that number is because we're doing this number times 3 because it's 3 water, and then you're getting that. And since we're trying to find the mass of the BeC2O4, we don't really need this section. This section is kind of, you don't need it. And then we're gonna take the total AMU, or the total AMU of the BeC2O4, and then we're timesing that by the molar mass at the end of the reaction, because that's how you find the grams. And then once you do that, you're gonna get 2.06, which is, get that out of here. You're gonna get 2.06, which is the answer. So yeah. Okay, so I'm not exactly sure this is exactly how you do it, but this is how the student teacher told us to do it, and it kind of makes sense. This is
what we're gonna do, yeah.
Okay, so basically, if you go on your pink sheet to find like the the question is calculate the volume of the water vapor release measured at 220 degrees Celsius and 1.5
ATM.
Okay, so basically you're gonna go on your pink sheet, and if you look at the equations, you're gonna find PV equals nRT, which means that wait, hold on, I have to look at what it means, sorry. Which means that the pressure in AMTM,
V is the volume
equals the number of moles in the water vapor, or the number of moles times the ideal gas constant, which is 8.1 or 31, which is on the pink sheet, and then the T in temperature in Kelvin.
Remember, it's Kelvin.
So then, if we're trying to find the just V, you use a little algebra, blah blah, and you're gonna just divide this side by P, right? So the equation we're using is V equals nRT divided by P. Okay, that's important. Second thing we have to do is we have to convert our Celsius into Kelvin. So to do that, also on your pink sheet, you're gonna go the Celsius, which is a little hard to see here, but it's 220 plus the 273.15. Okay, so that's gonna equal 493.15. And then you just input all the numbers into the equation. So we're gonna do our molar our volume equals, which we're trying to find, our molar mass times our gas constant times our what is it called, temperature in Kelvin, and then you're going to divide that by our AMT, which is 1.05,
and you're going to get your answer,
which is 2.46 liters. It's actually like in the hundreds, but you're
liters?
divide.
Remember, guys, include signs.
Oh, that's my bad. Liters,
That's our answer.
and that's our answer. So.